Professor Smith again. In this example, I'm going to show you how to use your TVM solver to calculate the present value to reach a future investment goal. So in this example, suppose you want to take a trip to somewhere tropical 5 years from now, and you decide you'll need $5,000 to take that trip. To have that much money set aside in 5 years, how much money should you deposit now into a bank account paying 6% compounded quarterly? You can see the present value formula is given on the top of the screen, as well as the values from the example inputted, in the formula. However, I'm going to use the TVM solver to do this on my calculator. So you can see here I've put in 4 times 6 for my n, total number of payments or compounding period. So I got the 4 from quarterly compoundments, and I multiplied it by 6, the time in years, to get 24 compoundments. The I percent, oh look at, I got a mistake there. It should be 4 times 5 is 20. I percent is 6%. PV, I do not know. That's what I'm wishing to solve for. PMT is 0. The future value or future savings goal that I want is 5,000. And the payments per year and compoundments per year are equal to 4 because this is quarterly compoundment. So when I enter all that into my TVM solver and my calculator, on the TI, I'm going to put my cursor next to PV and press the green alpha button and then the enter key. And I get $3,712.35. If I wanted to solve for PV on the Casio, I would press F3. Please note that I have put a dollar sign on the front of my answer and rounded to the nearest cent. Taking a closer look at this problem and to how I plugged each value into the TVM solver that I did, I want to highlight the important parts. First of all, I have 5 years. I will need $5,000. So because I will need that 5,000 in 5 years, that means that it represents future value. And the other important numbers in here are the 6%, that's the interest percent, and quarterly compoundments. So because my compounding is quarterly, a 4 needs to go in as a factor, one of the numbers that gets multiplied for my n, and it also goes into the PYCY. Going back up to the n, I multiplied my quarterly compoundments 4 times a year by the 5 years that my money will be sitting in the bank to find that there are a total of 20 compounding periods. The I percent was given as 6%. There is nothing I need to do with that number 6 besides type it in where it belongs. I told you the PV is what I'm solving for. And how do I know that I'm solving for present value and not payment, for example, in this problem? Because those are the two unknowns that I held with a 0 placeholder. Well, I knew I had to solve for PV because it says how much money should you deposit now, like as in today or in the present, as opposed to asking what would my regular payments, plural, be, in which case we would be solving for a different line item here. Moving along to the next example, this is an annuity application. And you could see how beautiful that formula looks. Have fun. I changed this example slightly from the notes because there were too many 12s in it. So example 5 says, if I could get there, how much do you save in 5 years if you deposit 60 bucks at the end of each month into an account paying 11% compounded monthly? So important values here are 5 years, $60, and month is going to match with this 11%, which is also monthly. So those are all the important values I can pull out of this problem. So you can see that in my N, I filled out monthly compoundments for 5 years, or 12 times 5, which is 60. And this factor of monthly compoundments also goes into the PYCY. I made it in two columns so it would view on this page and screen. So don't be confused by that. The 11% is my interest percent. I put it right in there. The present value, I do not know. The payment, the regularly recurring monthly payment is $60. You could put a negative there if you wanted so it doesn't show up in future value, but it doesn't really matter. We never copy the negative. The future value is 0, and I already discussed the PY and CY, payments per year and compoundments per year, are both 12, once again because it's monthly compoundments. So if I had a TI, I would put my cursor next to the FV, press the green alpha button and the enter key to solve. On the Casio, I would have to press F5 to solve for the future value. So if you want to pause and type these values into your calculator and make sure you're going to get the same thing as I do, I'm about to reveal the answer. Drum roll, please. I get, it's going to be weird about where it's going to let me put things. See, $4,771.08. So if I wanted to have $4,771.08 at the end of 5 years, and I could find an account paying 11% compounded monthly, then payments of $60 per month would get me to this future savings goal. I didn't know what this future savings goal was before I started the problem, but now I do. So this is kind of close to our Tahiti vacation. Maybe if I were to make that payment 65 instead of 60, I might have enough, and surely I would have enough and a little bit left over for souvenirs. So you could try playing around with the TVM solver. You can solve for basically any one of the variables in there.